Good morning, dear students. In the previous videos, we have learned about the laws of the exponents. First was the product law. Whenever we are studying about the product law, the bases are same and we have to add the powers, right? Secondly, we have learned about the quotient law. Whenever their bases are same between the two numbers and we have to make a division of the two numbers, then always there is the subtraction of the powers. And third law that we have learned, it was the power law. Means if a raised to m and again it is raised to n, means double powers are there. In that case we make a multiplication of the powers, that means a raised to m multiplied by m. Now the similar things we have to learn today as well, some more exponents law. For example, if the bases are different, a and b, two different bases are there and their common power is n, in that case this n is common for a and also it is common for b. So we can write it in this way, a raised to n multiplied by b raised to n. One example is there to understand this law. A raised to 5 multiplied by b raised to minus 3 and this whole bracket is raised to 4. That means this 4 is common for the first term and also it is for the second one. So it will become 5 multiplied by 4 and minus 3 multiplied by 4, right? So multiplication of these two. If we make a multiplication of 5 and 4, we are getting 20, a raised to 20. And multiplication of minus 3 and 4, it gives us minus 12. Okay. Similarly, another example, 3 raised to 4 multiplied by 5 raised to minus 3 and the whole bracket is raised to minus 2. So in that case also, minus 4 is multiplied by minus 2. Got it? And this minus 2 is also for this minus 3. So minus 2. Got it? So 4 multiplied by minus 2 is minus 8 and minus 3 multiplied by minus 2 minus multiplied by minus will be the positive sign and we are getting 5 raised to 6. Is that clear? Okay. Now the second thing is about the division. A and b, two different bases are there in the division form and raised to n is there. So that means it is n common for a and also it is for b. So we can write a raised to n and b raised to n. Example is there, a raised to minus 3 upon b raised to 4 and everything is raised to 6. So this 6 is common for numerator and also for denominator. So make a multiplication, means we have given this 6 to both numerator and denominator. Multiplication of 6 and minus 3 gives us minus 18 and 6 4s are 24. Got it? Now there are some new laws. Now this n root sign is there and in this v type of cavity n is written over there. So this n is called as order of the root. What is this n is called as? Order of the root. Okay. So this order we can write nth root of a, or the same thing we can write it in the form a raised to 1 upon n. Got it? Whatever the order is there, we have to take a reciprocal of that, 1 upon n. See, root of 3, or we can write it as square root of 3. So the order is not there, nothing is written over there. That means it is understood that always 2 is there. Okay, if nothing is there in the v cavity, that means always 2 should be there. So we can read it as square root of 3. So if 2 is here, we can write 3 raised to 1 upon 2. If nothing is there in the order sign, then we must understand that always 2 is there. Okay. Similarly, fifth root of 3 upon 7. Fifth root can be written as 1 upon 5. 3 upon 7 raised to 1 upon 5. This is third root, or we can also say cube root of 15. So this 3 can be written as 1 upon 3. Means whatever the order of root is there, we should take a reciprocal of that. Understood this thing? Now next. Now there are the two things. Order and also the power of base is there. Root and power, both things are there. So this m will get, means we can write it in the terms m upon n. Always the order should be in the denominator. Order of the root should be in the denominator. Okay. For example, cube root of a raised to 7. So what we have done here, it will be 7 should be in the numerator and then 3 must be as a denominator. Okay. So what we will write it, 7 upon 3. It will be 7 upon 3. 7 upon 3. A raised to 7 upon 3. See, the order is there in the denominator. Also 8 is there. Next 8 is there. So here 8 will be in the denominator and this power should be a numerator. So 5 upon 7, 3 upon 8. Got it? Next, we will start with the exercise 2b. In this exercise, first question, compute first 4 raised to 7 and everything is raised to 2 multiplied by 4 raised to minus 3, everything is raised to 4. According to our Powers law, what we have to do, multiplication of 7 and 2, the multiplication of 7 and 2 is 14. Similarly, the multiplication of minus 3 and 4 will be minus 12. Now, since the bases are equal and between the bases there is a multiplication sign, so we can apply the product law. According to the product law, we can make the addition of 4, 14 and minus 12. Okay, addition of 14 and minus 12. So 14 plus minus 12 by using the product law. So plus minus will be minus, 14 minus 12 will be 2. It means 4 raised to 2. 4 raised to 2 means 4 multiplied by 4. The final answer will be 16. Got it? Next, fourth one, 2 upon 3 raised to minus 4 multiplied by 27 upon 8 raised to minus 2. So this 27 and 8 can be simplified, means 27 can be written as 3 into 3 into 3. That means 27 can be written as 3 into 3 into 3, which can be written as 3 raised to 3. And similarly, this 8 can be written as 2 into 2 into 2. That means 2 raised to 3. Got it? So this 27 upon 8 can be written as 3 by 2 and common is cube, minus 2. Got it? So first number remains same as it is. Then by using the power law, 3 multiplied by minus 2 gives us minus 6. Got it? Then if we want to make this negative power as a positive power, we can take a reciprocal of this. So it becomes 2 upon 3 and see this minus 6 becomes plus 6 as a positive power by taking the reciprocal of this number. Now bases are equal. Since the bases are equal, we can apply the product law and addition of the powers. So minus 4 plus 6 becomes 2. So 2 upon 3 raised to 2. It means 2 multiplied by 2 is 4. 3 multiplied by 3 is 9. Got it? So 2 by 3 raised to 2. Square of 2 is 4 and square of 3 is 9. Okay. Next is the fifth question that we are learning. See, anything raised to 0. We know that anything raised to 0 is 1. So we have substituted by 1. Okay. Actually it was minus 3. So 2 upon 5 raised to minus 3 multiplied by 16 upon 25. Okay, so see what we have done. If the negative power is there, we made it positive by taking reciprocal of 2 upon 5. So reciprocal of 2 upon 5 will be 5 upon 3 and the power becomes positive. Okay, multiplied by 16. 16 means 16 can be written as 2 into 2 into 2 into 2. That means 2 raised to 4. So 16 can be represented by 2 raised to 4. Understood? And similarly 25. 25 means what? 5 into 5. That means 5 square. Okay. So this 3 is common for both numerator and denominator. So we separated this 5 raised to 3 and 2 raised to 3. Okay. Now let us find out where are the same bases. So 5 raised to 3 and 5 raised to 2. Okay. These are the same bases. Since both of these numbers are in denominator, therefore there will be the subtraction of their powers. So 3 minus 2, subtraction of the powers. Got it? And similarly, same bases are with this number and also with this. They have the same base, 2 raised to 4 and 2 raised to 3. So again they are in the division, so subtraction of their powers. 4 minus 3, subtraction of their powers. Understood? So subtraction of these two gives us 1. Again subtraction of these two gives us 1. So multiplication of whole this, multiplication of everything gives us 10. Okay. Next is our question number 8. So first of all, see the basis of each of them is same. 1 upon 3 minus 1 upon 3 minus 1. All the bases are equal. Always we will make a division first. So for the division, subtraction of the powers. 4 minus 8. Got it? Multiplied by the same number as it is. So 4 minus 8 gives us minus 4. Multiplied by 1 minus 1 by 3 raised to 5. So minus plus means again the bases are equal. By using the product law we can make the addition of their powers. Minus 4 and plus 5. Addition of the powers. So minus plus will be minus and sign of the greater number. So the final answer is minus 1 upon 3. Okay. Next question. Question number 13th. 125 raised to minus 2 by 3 divided by 8 raised to 2 by 3. So 125. This 125 can be written as 5 into 5 into 5. That means 5 cube. Got it? So therefore this 125 we can write it 5 cube and minus 2 by 3 remains same. Got it? Divided by also this 8. 8 also can be written as 2 into 2 into 2, which is equals to 2 cube. Okay. So therefore instead of the 8 we can write 2 cube and this power 2 by 3 remains same. Now by using the product law, make a multiplication of these two. So 3 get cancelled and 5 raised to minus 2 is the remaining value. Similarly, by making a multiplication of these two, 3 get cancelled, 2 raised to 2. Now since the power is negative, to make this negative power as a positive power, we will take a reciprocal of 5, that is 1 upon 5 square. And since it is a division sign, the rule says that make it multiplication and take a reciprocal of this. So we make it as a multiplication and reciprocal of 2 square becomes 1 upon 2 square. So 5 into 5 is 25. 2 into 2 is 4. It means 1 upon 25 multiplied by 1 upon 4 gives us 1 upon 100. Okay. Next, minus 3 raised to 4 minus 4th root of 3 raised to 0 multiplied by minus 2 raised to 5 divided by 64 raised to 2 by 3. Okay. Now, first, since the power is even number, whenever the power of any negative integer is an even number, always the answer must be positive. So therefore what we have done, we know that the value final answer of this should be positive. So we made it as positive 3 raised to 4 minus anything raised to 0. Anything raised to 0 is what? 1. So that means this value becomes 1. Okay. Now minus 2 raised to 5. Since the power is an odd number, it remains negative, minus 2, divided by 64. So this 64 can be written as what? 2 into 2, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. That means 1, 2, 3, 4, 5, 6. It means 2 raised to 6 is the value for 64. Got it? And therefore this 64 is replaced by 2 raised to 6. And this 2 by 3 remains same. Understood till here? Now 3 raised to 4. 3 raised to 4 becomes 81. It means 3 into 3 into 3 into 3, 4 times multiplication gives us 81. This one as it is, multiplied by minus 2 raised to 5 divided by cancellation. 3 1s are 3, 3 2s are 6, 2 2s are 4. That means 2 raised to 4. Now, as we know, the answer of this is negative. So minus 1 is multiplied to this minus sign. It will become plus 2 raised to 5. Understood how the sign is changed? When this minus 1 is multiplied to the minus 2 raised to 5, the value becomes plus 2 raised to 5. Got it? Now since the basis of these two numbers is same, between them there is a division sign. So whenever the division is there, we can apply the quotient law and difference of their powers, 5 minus 4. Okay, so 5 minus 4 gives us 1. 2 raised to 1 means 2. 81 as it is. 81 plus 2 gives us 83 as a final answer. Right?